Welcome to the course, The Introduction to Quantum Computing, prepared for you by the St. Petersburg State University. My name is Sergey Sisoyev, and I'm going to teach all the modules of this course. So prepare yourself to see and hear me often during the following 5 weeks. On the slide you can see the week's plan, which I call The Introduction to Introduction, since the course itself is called The Introduction to Quantum Computing, and the aim of this module is to introduce this course. Let's do it. And the first question is what it is all about. And to answer this question, I'm going to answer first another question, the negative one. I'm going to tell you not what this course is, but what it is not. So first, it is not a course on quantum mechanics, not at all. All the course material is based on the mathematical model of quantum computing, so even the basic knowledge in quantum mechanics is not necessary to understand the course material. Second, it is not the software engineering course. The word computing may mislead you, so here's your warning. We are not going to learn computer languages, programming languages, data structures, etc. Yes, we are going to design some algorithms, but this course will not probably improve your programming skills in the way you might expect. Now, when we know what we are not going to know, let's see what's left. First, we are going to learn the mathematical model of quantum computing, introduced by the quantum computing pioneer, David Deutsch. This model is a very powerful tool for us because it allows us not to dig in the physical nature of quantum computing, of a quantum computer, and to design quantum algorithms without even understanding quantum mechanics. And we are going to design, with this mathematical model, some quantum algorithms. So, the learning objectives are: first, to understand what these words, quantum computing, even mean. Why there's so much talk about them these days? Why exactly a quantum computer is believed to be so powerful? And is it our future or it's not? And I hope to clarify some of these things during this first week. Second, we are going to learn some quantum algorithms, but not just learn them. We are going to understand the principles of their design. So this is why I write here the design skills, the skills of a computer programmer, a quantum computer programmer. And quite briefly, we are going to understand that quantum computers are not really the next generation of computing in the common sense. They are not going to substitute the classical computers completely, because there are tasks that for which these quantum computers perform the same as classical ones. The prerequisites for this course are linear algebra. You have to understand what it is a linear space over some scalar field, what matrices are, what vectors are, how a matrix defines an operator, and how to apply this operator to a vector, and what other operations are there in these spaces. And the spaces we are going to discuss are all over the field of complex numbers, so they are Hilbert spaces, not Euclidean. So there are slightly different notions of an angle and a scalar product. And of course, to understand why the quantum computers are more powerful than classical, you have to understand what classical computing is. You have to understand what it is an algorithm and what it is a complexity of an algorithm, etc. Learning and understanding is impossible without exercises. So there are going to be exercises in this course. You will often have the in-video questions placed there for you to reflect on the new material, and the week tests, which are slightly more complicated than these in-video questions. And sometimes they're designed not to test your knowledge, but to extend it. And of course, these week tests are mandatory for obtaining the course certificate for those who want it. The course is called the Introduction to Quantum Computing, which means that there is very much more to learn. And here are some places to start. The most extensive course on the subject, to my knowledge, is John Preskill's course on quantum computing, available in the form of lecture notes on his site, on his internet page in Caltech University. Umesh Vazirani once had a course on quantum computing on Coursera. Unfortunately, I don't know what happened to this course, but if you would be able to find it, consider yourself very lucky, since the course was very good, and there are other lectures of Dr. Vazirani on the internet on some other topics, not from this course. And I also would like to recommend you some popular science books of computer science pioneer, another computer science pioneer, David Deutsch, The Fabric of Reality and The Beginning of Infinity. And I understand that it's quite uncommon to recommend the popular science books in the courses like this, but still I would like to do it, and I believe that these two books can improve your understanding of the subject. And according to this slide, we have just finished the first step, so let's go further.